good morning, everyone. Hope all is well. Hope everyone's doing all right. We are going to wait a couple seconds, make sure everyone's connected. Got a few people switching to audio, and we'll go ahead and get started. If you want to go ahead and start copying notes, this is where we're starting today. 3.2, looking at the empirical rule. As a matter of fact, let me get my headphones. Give me 1 second. All right, so let's go ahead and get rolling. Hopefully everybody can hear me okay. So last class we ended with notation and we did 3.2. So we didn't finish 3.2. This is where we're picking up today. The empirical rule still in 3.2. So the empirical rule says that 68% of the data is within one standard deviation, SD is standard deviation of the mean. Then it says approximately 95% of the data is within two standard deviations of the mean. Then approximately 99.7% of the data is within three standard deviations of the mean. So I'll give you a chance to go ahead and write that down. But we have a diagram that actually displays these three statements. Well, give you a chance to write it down. All right, scrolling up some. Of course, if I scroll too far, let me know. So this is the diagram that goes along with those three statements. This is our normal distribution. Remember we talked about that on the first day of class. Our normal distribution, a bell-shaped curve. We have the mean that's in the middle. That's Greek letter mu. Have our mean that's in the middle. 50% of your data is to the right of the mean. 50% of the data is to the left of the mean. So all of these percentages, I'm trying to get my pen out. All these percentages over here add up to 50%. All these percentages over here add up to 50%. So that's added up all together is 100%. And so within one standard deviation, it's 68% of your data. 34 and 34 give you that 68. Then if you go two standard deviations out, plus and negative, if you were to add up these four, that's 95% of your data. Then if you add up all of these percentages, that'll give you 99.7% of your data. And if you notice the 0.15 is 0.3, that'll give you 100%. All right, so that's just a diagram that explains those three statements. Also, it gives you room, and you'll see when we get to the examples, to be able to do different type of things like predict, the percentage of certain things happening within, certain numbers. You'll see when we get the numbers. Let me say it like that. But I'll give you guys a chance to copy. All right, can I scroll up? All right, so looking at our first example, trying to implement the empirical rule, says the mean IQ score of students enrolled at University A is 100 and standard deviation is 16.1. Anybody still holding on to the diagram? Very good. Oh, and I didn't even call out these numbers just in case anybody was, missing. This is 0.15, this is 2.35, 13.5, then we have 34. Then those same numbers on the right side, 34, 13.5, 2.35, 0.15. And those percentages never change. That's the empirical rule. Those percentages always stay the same. Now, these numbers down bottom will change according to, we get the standard deviation and the mean. And you'll see that in a second. All right. So determine, DET, just short for determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. Determine the percentage of students who have scores between 67.8 and 132.2. And then determine the percentage of students who have scores above 132.2. So I'll give you a chance to write it down for those who are writing it down. All right, can we scroll up? All right. So first thing we recognize that they gave us the mean and they gave us the standard deviation. So and normally in these type of problems, you don't have to find it. But if you do, remember, I told you use the app or the website to be able to calculate standard deviation. But they gave us a standard deviation to mean. The mean is 100, standard deviation 16.1. So I use the population symbols. Remember we talked about last class, symbolism notation. Greek letter mu is your standard deviation. Sigma is your standard deviation. Hold on. Mean is your mean. Greek letter mu is your mean. Sorry about that. And sigma is your standard deviation. And then here I was just notating that if we were dealing with a sample, it would have been X bar and S. So now when you go back here, notice we have our mean in the middle, then we have the right side of the mean, left side of the mean as far as calculating these values. So I'm going to do the right side of the mean first, then I'll calculate the left side of the mean, those 3 values. So this is what we have here in the green. So is your mean plus 1 standard deviation. Remember our mean is 100, 1 standard deviation is 16.1. And so that's how you get 116.1. Then add another one to be 2 standard deviations out. And that's how you get 132.2. And then add another one more time, that's 148.3. And so this is 1 standard deviation above the mean, 2 standard deviations above the mean, and then 3 standard deviations above the mean. That's the right side of your empirical rule. All right. Questions on those 3 values, how we got those 3 values? So to get the other 3 values to the left of your mean, you subtract them. So there's 100 subtract 16.1, which is 83.9. Subtract 16.1 again, 67.8. Subtract 16.1 one more time, that's 51.7. All right. Any questions with those 6 values? Let's scroll up. All right. So this is how it will work for us. So notice we got our mean in the middle. Remember I told you these percentages do not change. Those are your empirical rule percentages. And then on bottom, those are the numbers we just calculated with the mean in the middle. Values to the right, values to the left. So before we go and answer the questions A, B, and C, probably what we did. Or any questions about what we just did? All right. Very good. Can we go and start answering the questions? All right, so let's look at A. Determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. Now, we actually did not have to do any of the calculations that we just did to answer this question. If we're talking about IQ scores being within 3 standard deviations of the mean according to the empirical rule, what empirical rule says that approximately 99.7% of your data will be within 3 standard deviations of the mean. So that's the empirical rule. So that's what A is. A is 99.7. All right. Questions on A. A was just based on generically the empirical rule. What does it say about being within 3 standard deviations of the mean? All right. So now B is more specific. It says determine the percentage of students who have scores between 67.8 and 132.2. So we see we have 67.8 right here, 132.2. So you just take these values and add them together. And that's 95%. All right. Questions on B before we go C? All right. C, determine the percentage of students who have scores above 132.2. All right. So 132 is right here. And then you say above. So you're talking about these values, these percentages. So you add the 2.35 and the 0.15 and you get 2.5%. All right, questions? Any questions? All right. Can we go to 3, 4? Now there is no 3, 3 for us. You're just doing 3, 1, 3, 2, 3, 4, 3, 5. All right. So any problems with 3, 2 before we go to 3, 4? All right. So 3.4 measures of position. and outliers. Yeah. So z-scores, the distance of data value is from the mean in terms of standard deviation. So that's generally what our z-scores are going to be. So the general formula for your z-scores is your data value minus the mean divided by the standard deviation. And so in green, you see population symbols, purple sample symbols, but it's still saying the same thing generally. It's your data value minus the mean divided by the standard deviation. No matter what symbols you use to calculate your z-score, there's always your data value minus the mean divided by your standard deviation. All right, any problems? Can I scroll up? Couple of statements about z-score that Math Lab may ask you. The z-score is unitless and it has a mean of 0, standard deviation of 1. I believe most definitely that's a statement that I've seen before in the homeworks. That doesn't mean you're when you go to our z-score chart, and we're going to go there. You guys won't see a z-score chart until chapter 7, I believe. Anyway, when we get there, you'll see that when you convert everything to z-scores, your mean is in the middle with 0, and then everything else, fits your normal distribution curve, but 0 is in the middle as your mean. All right, scrolling up. All right, so determine whether the Angels or Rockies had a relatively better run producing season. So we're talking about baseball here. The Angels scored 773 runs and play in the American League, where the mean was 677.4 and the standard deviation was 51.7. The Rockies scored 755 and play in the National League, where the mean was 640 and standard deviation was 55.9. So I'll give you guys a chance to write it down for those who are doing so. So in order for us to figure out which one had a better run producing season, if you never watch baseball or you don't watch it that much, your American League and the National League have a little bit different rules when it comes to doing different things in baseball. So that's why it's relative and it's a purpose in seeing or comparing the Rockies to the National League runs and the Angels to the American League runs, because they do things a little different within their leagues. So what we're going to do is convert the Angels runs to a z-score, and that z-score is based on what goes on in the American League, and then convert the National League, not the National League, the Rockies to a z-score, which is based upon the National League findings. So we do both of them individually. And so this is the information that we pulled from the problem. The Angels had the runs of 773. The mean in the American League, 677.4, standard deviation 51.7. The Rockies had runs of 755. The mean there, 640, with standard deviation 55.9. All right, once again, that's no calculation. We just pulled that from the problem. And now we convert both of them to z-scores. Remember, that's your data value, which is x, minus your mean, which is mu, divided by standard deviation, which is sigma. So for the Angels, 773 minus 677.4 divided by 51.7 gives us 1.85 as a z-score. And then the Rockies, 755 minus 640 divided by 55.9 gives us 2.06. And yep, I got the statement right there. And so with our z-scores, we're always going to round z-scores to 2 decimal places. And that's going to matter when we go to our z-score chart, basically, like I said, in the future, but might as well get in the habit of doing that now. So you always round your z-scores to 2 decimal places. All right, any problems, questions before I scroll up? All right, so that 1.85. Now, it does matter if your z-score is positive versus negative. When we talked about being above the mean versus being below the mean. If it's positive, it's above the mean. If it's negative, it's below the mean. So the Angels scored 1.85 standard deviations above the mean. The Rockies scored 2.06 standard deviations above the mean. So that means the Rockies had a better run producing season or a better run producing year. All right, can I scroll up? All right, so percentiles. The kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. I'm trying to write some of this stuff a little better. I got better at writing on this as I got better, more practice. So I could tell that a lot of this stuff was done earlier. All right. Kth percentile is denoted by P sub K. All right. So this is an example of how percentiles are used by holding on to black. I'll start right there. So Jennifer just received results of her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does this mean? All right. So 74% of the people who took the exam scored 600 or less. Because remember, it represents, you go back to what I said here, the observations are less than or equal to the value. So 74% of the people who took this exam scored 600 or less. And so that means that 26% scored better than her. And then you get a 26 from 100 minus 74. All right, are we good to scroll up? All right, so quartiles. Quartiles divide the data set into fourths. So if you look at this mini diagram, have our quartiles in the middle, Q1, Q2, and Q3. Then on the ends, we have the minimum or the smallest value. And then on the maximum value on the other end. All right. So let's look at how we would find our quartiles. Drop my pen, give me a second. Okay, so the first thing we want to do is list our data values from least to greatest. So don't forget this statement because we have to do that first. All right, so find Q2. We want to find our second quartile first. It's going to be the median of the whole data set. Then we would find Q1. That's the median of the first half of data. And then find Q3, which is the median of the second half of data. All right, can I scroll up? So before we go into actually doing an example, thank you, sir, appreciate it. Before we go into finding the actual quartiles, I'm going to give you this other piece, the interquartile range, and then we'll just, find it all at one time. Interquartile range, IQR, that's the range of the middle 50% of the data set. And you find your IQR by taking Q3 and minusing Q1 from it. All right, and then one more thing. I think this last thing before we get into it. Yep. And then the last thing before getting into a problem, checking for outliers. So outliers are extreme values in reference to the data set. So they can be very, very large or very, very small. So that's what I was saying right here. Very large or very small values in comparison to your data set. So what we're going to do is, instead of just eyeballing it and looking at these numbers, say, hey, that looks like a very large number, or that looks like a very, very small number. We're going to have these fences or boundaries, depending on the book that you have. I believe our book called them fences. We have an upper fence and a lower fence. Our upper fence is Q3 plus 1.5 times IQR. Lower fence, Q1 minus 1.5 times IQR. 1.5 is just a part of the formula. Your IQR is what we're going to get, right here where we calculate. And so that will establish a number in each case, a upper number and a lower number. If any number is greater than the upper fence, and I have that statement down here, if any number is greater than the upper fence, then it is an outlier. If it's less than the lower fence, then it is an outlier. So you're going to have these boundaries or fences that will establish if you have an outlier or not. All right, can we scroll up? Do an example. So what we're going to do is follow these steps. We're going to follow the steps to get into quartiles, and then we're going to find an IQR. Then we're going to use establish your upper and lower fence and see if we have any outliers. Of course, let me know if I scroll up too far. Somebody's still copying the green. Okay. So we have our data set right here. I'm going to erase some of these circles just to make sure it's clear on what's what. So we have this data set right here. We listed from least to greatest. I went ahead and listed our data set from least to greatest just for board purposes, no purpose in writing down numbers, multiple times, just write it down one time. We have our smallest value, which is 180, largest value is 21,147, and I've listed it from least to greatest. Notice how I set up my data set. Normally I try to go ahead and split it up in half if I can. So we had 18 data values altogether. So I wrote 9 up here, 9 down here, just to help me with establishing what my medians are going to be and all the good stuff like that. All right. So I'll put my circles back because There we go. Help me establish some things. So I have 9 data values in my first half of data, 9 data values in my second half of data. Altogether, I have 18 data values. So don't forget, whenever you're trying to find your median, the first thing we need to do is list our data values from least to greatest. And then my middle value, I can just pick it out if I have an odd number of data values. If this was 19, then all I would do is pick out the middle number. But I have 18, so I don't have a middle number. I have to actually calculate it. And that's what I did here. Q2 is your median of your whole data set. So I took my 2 middle values, add them together and divided by 2. And that gives me 1805. Once again, if I had 19 data values, I would just have a middle number and I wouldn't have to do any calculation. All right. So I tried to color code what I was doing. So the Q2 goes with the purple. So remember, that's the first one you find. You find Q2, which is the middle data value of your whole data set. Then you go to find Q1, which is the middle data value of your first half of data. Now, remember, I have 9 data values in the first half of data. So that means I have a middle number, which is 735. I don't need to calculate because I have an odd number of data values. Then the same thing goes with my second half of data. I have 9 data values, so there's nothing to calculate. Just pick out the middle number, which is 4668. Any questions up to step 4? Any questions? Step 5, find your IQR. It's Q3 minus Q1. Oh, then right, I'm sorry, didn't go up far enough. That gives us 3933. Now, step 6, we want to determine our fences. Remember, these are the numbers that's going to establish if I have an outlier or not. So we have an upper fence and lower fence. Everybody still holding on to number 5? All right. So our upper fence, Q3 plus 1.5 times IQR. So that's 4668 plus 1.5 times 3933. That gives us 10,567.5. Then our lower fence, Q1 minus 1.5 times IQR. So it's 735 minus 1.5 times 3933. And that ends up giving us negative 5164.5. Any questions before we look at the last step? All right. So the last step, are there any outliers? So you look at your upper fence, lower fence, go back to your data set. Remember our data set was right here. Look at 180, look at 21, 147. Ask yourself, any of these values less than our lower fence or greater than our upper fence? And the answer is yes, 21, 147 is greater than our upper fence of 10,567.5. And it is possible to have more than one outlier. So the marker is your upper fence on the right, lower fence on the left. If something is greater than the upper fence, it's an outlier. If it's less than the lower fence, it is an outlier. Any questions? Any questions? I'm gonna do this process again one more time. But any questions on what we've done up to this point? All right, all right. So we can go to the next page. Everybody good? Okay. So 3.5 is the exact same process, except they add the 5-number summary, which all it is that we're just labeling what we just did. So yeah, it's not really, oh yeah, the 5-number summary and box plots. So which is still based on this right here. So you'll see in a second, but it's still the same process we just walked through. We're gonna do that again and just label 5-number summary, box plot. Okay, so the 5-number summary is your minimum, Q1, Q2, Q3, and your maximum. Yeah, 5 numbers that summarize your data. All right, so then your box plot. Anybody holding on to the purple? All right, so your box plots, graphical tool used to compare groups of data. It consists of a box with lines that are extended to the minimum and maximum values that are not outliers. So that's going to be key. These lines are called whiskers, and then outliers are represented by an asterisk. All right, that's a generic representation of your box plot. Notice you have Q1, Q2, and Q3 that represents vertical lines of your box. And then extended from the box, it goes to your minimum and maximum values. And then if you have any outliers, you can represent them by asterisks. All right. So the directions could be give the file number summary and sketch the box plot. So notice it doesn't tell us to go through the process that we just finished going through. But in order for you to get your Q1, Q2, Q3, that's your quartiles. That's what we didn't finish doing. And then also establishing what numbers are actually outliers. We had to go through all of those steps. So really it's telling us to do that without telling us to do that. All right. So this is just in red, just a reminder, data set's not always written from least to greatest. Make sure this is the case before you move forward. So remember that was the first step to write your data set from least to greatest. Give you a chance to write that. All right. So once again, I went ahead and wrote my data set from least to greatest before we got on the board. So we have 21 data values here. And once again, let me erase this. So once again, I set mine up where I wrote half my data here, half my data here. Now, since I have 21 data values, I went ahead and wrote the middle one in the middle. So once again, it's up to you how you want to establish, setting up your stuff. But it's always easiest for me to go ahead and split stuff up in half. So I'll know how to operate moving forward, looking at the first half data, second half data, stuff, things like that. And so once again, I have an odd number of data values. So when I split my data set in half, I have half my middle number, and then my other half. So trying to pull my stuff back. Trying to keep my color coding. All right. So if I have 21 data values altogether, that means 10 values. 10 data values are my first half of data, 10 data values are my second half of data. And I have a middle number. And remember, that's the first goal, is to find your Q2, which is the median of your whole set of data. In this case, we didn't have to calculate for it because we had an odd number of data values. And that was 30.95 is in the middle. So since I have 10 data values in my first half of data, 10 data values in my second half of data, that means I don't have a legit middle number because I have an even number of data values. So I'm going to take the two middle numbers, add them together, divide by 2 in both cases. So Q1, to find my median, I took 25.83 plus 26.28 divided by 2, and that gives me 26.06. All right. Do the same thing for Q3. This time our two middle values, 37.05, 37.43. Add them together, divide by 2, that'd be 37.24. All right, any problems with up to step 4? All right. So Q3, not Q3. IQR is taking Q3 minus Q1. That'd be 37.24 minus 27.06, 11.18. All right, then we can find our fences. Another book called on limits, whether you call them boundaries, limits, or fences, same calculation. Our lower fence is Q1 minus 1.5 times the IQR. That ends up giving us 9.29. Then Q3 plus 1.5 times the IQR to find our upper fence. That ends up giving us 54.05. All right, and then red statement just to reaffirm what we know our fences to be. If a value is less than the lower fence or greater than the upper fence, it is an outlier. And so we can compare our data set, our data values to the fences to determine what our outliers are. And 54.63 is an outlier because it is greater than the upper fence. All right, any problems with steps 1 through 7 before we get to what they actually asked us, which is the 5-number summary and the box plot? All right. All right, first things, 5-number summary. Now, the 5-number summary has nothing to do with whether something is an outlier or not. It's just what is the maximum value, what is the minimum value, what is Q1, Q2, Q3. All right, so that's your 5-number summary. We have our maximum, minimum, Q1, Q2, and Q3. Any problems with the 5-number summary? Okay. Here is the box plot. So once again, your vertical lines of your box, that's Q1, Q2, Q3. Your whiskers, which are your horizontal lines that extend away from the box, will go to your maximum and minimum value that are not outliers. So 19.95 was our smallest value. We found that one to be okay. Now our maximum value was 54.63, but it was an outlier. So the whisker does not extend to the 54.63. We represent that as an asterisk. And then we take the next number up, which is 49.17. And that's what the whisker will extend to. All right. Questions on what we did here? And okay, yeah. All right, is everybody good? Everybody straight? Everybody okay? All right, so let's make sure we're clear on where you guys are, where we are in the class. We talked about chapter 1, chapter 2. Oh, yeah, this is what I want right here. So up to this point, we've covered up to chapter 3. So that's the homework that you're responsible for, chapters 1, 2, and 3 up to this point. You got the test 1 out there, chapter 1 and chapter 2. If you have not given me your definitions, make sure you get that to me. That's off of chapter 1, chapter 2. There are assignments, if you were to look, I'll show it to you. Let me see if I've got MathLab still open. Hold on 1 second. It's probably not. Yep, kick me out. Give me 1 second. All right, so we got a definition right here, but you see we have the assignments. You do not have to do those. Since it's a summer short session or whatever, I just rather you guys just focus on getting your MathLab work done. So do not do these assignments here. All right, any questions on that? Everybody see them? No problems. So don't do assignment 1, 2, or 3. Just rather you, of course, get those definitions. We already talked about it, but then just, attack your homework. Make sure you get your homework done. All right. And so test 2, we don't have to worry about right now because that has 3 and 4 on it. So we'll get into chapter 4 next class. And chapter 4 is 4.1, 4.2, and 4.3. I have another class that goes to 4.4. That's 155. But you guys, so it's only 3 sections that's in chapter 4. So. All right. Questions? Any questions? See somebody in the chat? Oh, when it comes to due dates and homework, everything is due by 8/5. So the way you can gauge yourself, though, to say, okay, if I'm behind or not, is where we are in the lecture. So you just want to try to do your best to keep pace or be around it. You don't have to be exactly, when we come back from next class, you don't have to be done with chapter 3, but you do want to be in chapter 3 at some point so you can start getting it knocked out. And when do we have to have the test? Same thing. Every due date, if you were to go into MathLab right now, if I can get there, due date's 8/5. Everything should say 8/5. Yep, no problem, no problem. Now, if we have a proctored test, and I'll tell you well in advance if we're going to do that. I know we got to do at least one proctored test. We're going to do our final exam proctored. But if we are in proctored means that, we're going to sit in the class period. Y'all still Zoom in. You don't have to come into class. But, I'll watch you while you take it, that type of thing. You'll enable your cameras. Your final exam most definitely will be done that way. Probably have to get in at least one of these tests that way, but there will be options and stuff. We'll talk about it when we get there. Now that will have a due date because that will be during a class period. But if you get behind on the other stuff, it's no big deal. Just get caught up, that type of thing. All right. Anything else? Anybody else before we close today? All right. I believe that is enough for you guys. Unless y'all want some more, I think I got you till 1:30, right? Something like that. So, I think you guys had enough for today. Any comments, concerns, anything before I shoot you off to the weekends? Everybody good? Everybody straight? All right. Okay. So you guys have a great weekend. Be safe. Next class, I'll open up the floor for questions first. See if you guys have anything generated over the weekend. Remember, you have 3 chapters, to get into. So I'll open up the floor for questions first. See if you guys have any. If not, then we'll go ahead and get started with chapter 4. All right. You guys have a great weekend. Take care.
Have a good day.
Thanks. You do the same.